In this video we're going to talk about stem plots, sometimes known as stem and leaf plots. Now this is just a simple way of representing data. Statisticians often use different ways to represent different patterns in data or different types of distribution, and stem plots are a very simple way of representing what's happening to underlying data and represented in a way that's almost pictorial, and we'll see what I mean by that in a few moments. So a stem plot, or a stem and leaf plot, well, it shows exact values of individual observations. So it's not approximations, it's not estimations, it's the exact values of individual observations. And these exact values are taken and represented in the stem plot. Now, a stem plot is a way of showing quantitative data based on small data sets, typically 50 or fewer observations. So stem plots are not really useful for very large data sets. Generally speaking, about 50, less than 50 say maximum observations is best illustrated using stem plots. And it's quantitative data, it's not data which is continuous, or it's normally discrete data, so we can count it up and we can represent it. And there's an example of a stem and leaf, or a stem plot. And we'll just talk about what this means in a moment. But we can see it's a very straightforward picture. It's just a vertical line, and in this case the data runs from 0 through to 10. And on the right hand side we have what's known as the leaves, and we have some data in there. At the very bottom we've got a key, and I'll talk about that in a moment as well. So this stem plot shows the results of an end of year, say a school test in science for some particular class, let's say for the second graders. So the data here is the results of some form of assessment given to second graders in a school related to scientific topics, and this is how the students scored. In a stem plot, the entries on the left are called stems, as you can see, and the entries on the right are called leaves, again as you can see from the diagram. In the example, the stems are tens. Say, for example, 5 represents 50, 9 represents 90, 10 represents 100, and so on. And the leaves are ones. So the leaves are unitary values. However, the stem and leaves could be other units. They could be in millions or thousands or ones or tens, whatever we decide. In this case, we have it as the stems are 10 and the leaves are 1. So if we just look at, let's say, the stem for 5, which is 50, then someone got 55, someone got 53, someone got 55, someone got 52, and someone got 55 again. So I'm just reading across from the stem 5. Some stem plots include a key to help the users interpret the data correctly. The key in the stem plot above indicates that a stem of 10 and a leaf of 1, and it represents, let's say, an IQ score of 101, or in our case we've got a science test, so a 10 and a 1 would be 101 in the test. Well, we'll assume that all tests are marked out of 100, so that would not be very precise. But the key just simply tells us what's going on. What does the stem stand for? In this case, the stem stands for 10 and the leaves stand for 1. And then we can interpret specific stems and look at the associated leaves. So that's the key that we're discussing. Now, the stem and leaf diagram describes the distribution of test results. Most of the scores are clustered between 30 and 60, with the center falling in the neighborhood of around 45. So what we mean here is that the majority of the test's results in this science test we're talking about, the majority of them fell somewhere between 30% and 60%. That's the vast majority of students scored in that range. Very few scored less than 10. Very few scored more than 80. Well, as we've got it here, none scored more than 80. Just 2 got into the 80s. So the vast majority are in that banding. And if we just sketch around it, we can see that's roughly the case. The majority fall into the figures from 30 to 60. You can see that curve is bent away from the vertical line most with the 4 figure. So 4 would be what we call the modal figure. The majority of students got into the 40s. The next popular was 50s. And then the 60s and the 30s were equal in terms of the number who scored in there. 4 students were in the 30s, 4 students were in the 60s. 5 students were in the 50s and 6 students were in the 40s. The scores range from a low of 7 to a high of 100. The high score of 100 might be classified as an outlier because it wasn't actually achieved. So it should range from 0 to 100, but in fact, in this case, it gets to 86. 86 is the maximum score. So in that case, they didn't achieve the 100, so it could be classified as an outlier. Quite a strange thing to happen for a student to get exactly 100%, although it has happened. So we may view that as an outlier. Then, if it is considered as an outlier, then the range will be from 86 less 7, which would be 79. So the range of the observations covers 79. The minimum was 7 at the very bottom of the stem, and it goes up to 86. That's the maximum that was scored. So the range we can read off here as well. So we have an idea now of the mode and of the range. We could also guess at the average. It would be a guess, but we could guess ahead to be somewhere around 4, 4.5, because that's where the majority of the observations seem to be falling. And that's all we need to know about stem plots. Very simple, straightforward little exercise in how to represent data. So let's leave it at that and say thank you for watching.